Should it on the side? Anyway, if you're comfortable there, go to the next page. Wherever. Yeah, good evening, children. Good evening, online students. I've shared my screen now. Is it visible?
Yes, ma'am, it's
Good
visible.
evening. Yeah. Good evening, Gayatri, Lakshana, Anantika, Harsha, and Aishwarya.
Good evening.
Good evening. Yeah, good evening, sir. Shivam. Oh, yeah, good evening. Yeah. Yeah, children. So first, let's discuss the answers of the homework which I shared in the last class. Yeah. The answer for the first one, what's the side of the square path?
Ma'am, can Anantika say?
Yes, Anantika. Anybody? It's an open question. Whoever completed the homework and
Ma'am,
wants to share the answer can share it.
so to find out the side, we have to take the square root of 1281.64. So when we take the square root, we get 35.8, and then we have to multiply it by 4.
Oh, very good.
Yeah.
35.8. Very good.
We have
And
to
what's the
multiply-
perimeter?
Yeah, perimeter we have to multiply it by 4, so we get 143.2 meters.
Very good. Very good, Anantika. Perfect. Others, check your answer. You have not completed, is it? You should have requested me for the image. No reasons accepted. You could have requested me for the image, right? I would have shared it with you. And regarding not understanding the long division method, you should have requested for the recording. I would have shared that with you. You saw the recording. Yeah, then I'm going to say the same thing even if you ask me now. You watched the recording and didn't understand the long division, is it? No, அது practiceல தான் வரும். Practice பண்ணணும். அது practiceல தான் வரும். Yeah, online children. Honestly, tell me how many of you have not completed the assignment?
Ma'am, I just didn't get one question, otherwise I have done it.
Very good. Gayatri?
Ma'am, I didn't do the fourth.
Okay, fine. Lakshana?
Ma'am, I completed, ma'am. Ma'am,
Very
except
good.
the second question which I have as a doubt.
Okay. Harsha and Aishwarya?
Ma'am, I didn't get the third question.
Okay.
Ma'am, I haven't done it. Ma'am. I couldn't complete it.
Fourth. Harsha, fourth one. Aishwarya?
Ma'am, I was not able to complete it, ma'am. I only did the first two questions.
Okay. Okay, children, see, you have a lot of time to complete the assignment. So, anyways, I cannot do anything from my end if you have reasons for not completing it. I can only take your reason. Well, I cannot do anything beyond that. But what is expected is whatever is planned, you need to execute that. And it was not too much of an assignment. Even if you had tests or exams or whatever at school, This was barely 5 to 6 questions. Let me just check again.
Ma'am, 5 questions.
See, 5 questions. 5 questions. So even if you didn't have time to complete all the 5, you could have set aside at least 1 hour for this and try to do as much as possible in that 1 hour's time. Okay. There is time, children. There is time. When you want to do it, you will find time to do it. If it's an option, if it's a priority, you will find time to do it. If it's an option to do the homework, you will not find time to do it. So you should decide if homework should be a priority or an option. So, well, I think you should prioritize it. Yeah, this is the answer for the first one. So as Anantika rightly said, we need to find the square root of the given number to find the side of the square part. To find the side of the square part, we need to find the square root of the given number, that is the area, by long division method. This is the, no, don't write down now. I'll share the images. You can complete it at home. Okay, online students have an option to take the screenshots now. I'll share the images on WhatsApp later, all right? And we know that perimeter is 4 into side. So 4 into 35.8, 143.2 meters is the perimeter of the square park. Yeah. Second one.
Ma'am, can I say?
Yeah.
Ma'am, so for this one, the largest 4-digit number, which is 9,999, we will solve it by long division and we'll get the remainder as 198. So we'll subtract 9,909. We'll subtract 198 from 9,999, and we'll get 9,801, which is a perfect square number.
Very good. But I think this one I have not taught you so far, right? This type of question, has it been taught in the class? No.
No, ma'am,
No.
but I learned it
Okay.
in school, so.
Okay. Yeah, fine. You're right. Yeah. So children, let me explain this now. Find the largest 4-digit number. Find the largest 4-digit number that's a perfect square. Okay. Okay, let's find the largest 2-digit number that's a perfect square. Let us, to understand this procedure, let's find the largest 2-digit number. 2-digit number that's a perfect square. Now, which is the largest 2-digit number? Okay, let me write the question. 1 minute. Let me write the question. Find the question is find the largest 2-digit number. 2-digit number that is a perfect square. Now you can all guess this. It's easy. What is that number? Which is the largest 2-digit number, which is the perfect square?
16.
81. Correct? 9 9s are 81. 81 is the largest 2-digit number. That's a perfect square. Because after that, 10 10s are 100, which is a 3-digit number. The largest 2-digit number, which is a perfect square, is 9 into 9, 81. Because after that, it is 10 into 10, 100, which is a 3-digit number. So now you know the answer is 81. Now, how do we get this answer 81? We know that the answer is 81. 81 is the largest 2-digit number, which is a perfect square. Now, how do you get this answer? So take up the largest 2-digit number. To get this answer, first take up the largest 2-digit number. See, you need to find the largest 2-digit number, which is a perfect square. Now leave that word perfect square, which is the largest 2-digit number. 99. Take up that number and try to find its square root using the long division method. It's not a perfect square, so you will not get remainder 0. It is not a perfect square, so you will not get remainder 0. But let's perform the long division. So it will be what? 9 9s are 81. What's the remainder? What's the remainder? 18. 18. So the number which we have taken up minus the remainder. Minus the remainder. So 81 is the required number. So similarly here, we need to find the largest 4-digit number, which is a perfect square. So take up the largest 4-digit number. We need to find the largest 4-digit number. That's a perfect square. Ignore this word perfect square. Take up the largest 4-digit number. This is the largest 4-digit number. It's not a perfect square, but perform the long division, the square root long division. You will not get remainder 0. So the remainder is 198. Now 9,999 minus the remainder 188. Now, sorry, minus the remainder 198. You get 9801. This is the required 4-digit number, which is a perfect square. Now, when you try to find the square root of 9,801 using the long division method, you will get 0 remainder. So what's the procedure? You must, to find the largest 4-digit number that is a perfect square, you take up the largest 4-digit number. So the largest 4-digit number is this one. And perform the square root long division. You will not get remainder 0. The remainder is 198. Now, the required number is this one minus the remainder, which is 9,801. So this one is the largest 4-digit number, which is a perfect square. It is a 4-digit number. It is also a perfect square, and it is the greatest 4-digit number that's a perfect square. It is a perfect square. This number 9801 is a perfect square. It is a 4-digit number. And it is the greatest 4-digit number that's a perfect square.
Ma'am.
Okay. Yeah.
Ma'am, what if the question is like find the smallest 4-digit number that is a perfect square?
Yeah, we'll be doing it. I have those questions. Don't worry.
Yes, ma'am.
Yes, yes. That's then the next presentation. Yeah, there's the answer for the second one. Now, what is the least number? Similar question we did in the last class, right, children? Yes or no? Similar question, Surya? Yeah. What was the answer for the first one, Surya? You completed the assignment, Surya? Okay, what the second one you were not able to do, right? Because I hadn't done it in the class earlier. You did it? Oh, very good, very good. The third one. What is the least number by which 6,468 is to be multiplied to make it a perfect square? What's the answer, Surya? It's a number to be multiplied. Very good. Very good. So here Surya's got it right. 3 into 11, 33 is the smallest number. Online students, please acknowledge. How many of you have got this answer? Lakshana, you got this? 33 for a third.
Yes, ma'am.
Anantika?
Mom, I didn't get how to do this question.
Okay. Aishwarya?
Yes, ma'am, I got this third one.
Harsha?
Yes, ma'am, got the same answer.
Ariston?
Ma'am, I just now joined the class. It's just 2
Yeah.
minutes since I joined the class. I'll just come up with the question.
No. We're discussing the answers to the homework which I had given last week.
Okay,
Did you complete them?
No, ma'am, I have not completed it. I have to.
And Gayatri, you got this answer?
Yes, ma'am.
Very good. So children, I also told you the procedure to, to do the homework. You need to first go through the classwork of Monday and Wednesday and then try the assignment, because the assignment is based on whatever is taught in the class on Monday and Wednesday. So you cannot directly jump into doing the assignment. You need to revise what you've learned in the 2 classes and then try the assignment. So 33, because 3 and 11 do not occur in pairs. 3 and 11 do not occur in pairs. So 33 is the smallest number by which it should be multiplied to make it a perfect square. All right. Very good. Yeah. What's your answer, Surya? Yes.
Ma'am, so first we have to change it into improper fraction. So we'll get 11,236 upon 729.
Very
Then
good.
after that, we'll take the square root of 11,236, which is 106, and 729 square root, which will be 27. So the answer will be 106 upon 27.
Very good. And then you should convert the answer to a mixed fraction.
Oh, okay.
Yeah, very good. Good, Anantika. Very good, Surya. But you should not use 9. You should use only prime factors. It's okay. You got the answer, but you should use only prime factors. Very good. Very good. So I have used the long division method to find the. Okay, so let me tell you how this works. It's a mixed fraction. The given number is a mixed fraction. You need to find the square root of this mixed fraction. So the square root of this mixed fraction is equal to the square root of this improper fraction, correct? You need to change the given number to an improper fraction. It's mixed fraction, change it to an improper fraction. That's the first step. Then find the square root of the numerator and the square root of the denominator. Now that we know both the methods, the long division method and the prime factorization method, you choose to use the long division method. That works faster and it's easier than using the prime factorization method. That's okay. You have done it easily with that. That's fine. Anything is fine. So I have done it using the long division method. I have found the square root of the numerator and the square root of the denominator using the long division method. You can see it here. So now square root of 11,236 by 729 is equal to, what is the square root of this number? 106 here. And what's the square root of 729? 27. Correct? See, we have found the square root of the numerator and the denominator. Numerator and denominator. The square root is 106 and here it is 27. So this one is equal to 106 by 27. And write that as a mixed fraction. Right, that one is a mixed fraction. Convert 106 by 27 to a mixed fraction. How? By just dividing like this. 27 and 106. So 27, 3s are 81 and 25 is the remainder. So 325 by 27. 325 by 27. Can you show the sums, Tanya? It's time. You've asked them to come inside, no? Satakshi, the Ovia and Tanya. All right. Next one. Surya, is this number a perfect square? It's a perfect square. Give reason. Now, for this one, have you answered it using the long division method or the prime factorization method? You did both, but which is appropriate? No. You should do the prime factorization method. Only then you can give a reason.
Ma'am?
Very good. Your word tells me, but I'll talk about the reason. I'll tell you.
Ma'am,
Yes.
I did the long division method, but I still gave a reason. I'm not sure if it's correct.
Okay, what's the square root of the number given?
Ma'am, 238.
Okay, but no, my question was incorrect. Meaning the question I asked you now was incorrect. You don't have to find the square root here actually. Somebody's come, darling. Oh yeah, okay, yeah. What was I telling you? Yes, the question is it a perfect square? The question is it a perfect square? So you don't have to find the square root. See, for a question like this, you should use the prime factorization method. You should not use the long division method. you must use the prime factorization method because you'll have to give a reason. You'll have to give a reason. So see here, to check if a given number is a perfect square or not a perfect square, we need to factorize the given number. So factorize, do the prime factorization method like this. So 5, 6, yeah, see you, yeah. All right. So 56,644 is equal to 2 square into 7 square into 17 square. All right. 2 square, 7 square, 17 square. So now you can see that every prime occurs in pairs. Every prime factor is occurring in pairs. So it's a perfect square. Supposing you had 119 like this. 19 does not occur in pairs. There's only 119. So it's not a perfect square. See, you don't have to find the square root here. The question is not to find the square root. Is it a perfect square? Answer the question, is it a perfect square or not a perfect square? Now here the answer is yes, it is a perfect square. Why? Because every prime factor is occurring in pairs. There are 2 2s, 2 7s, 2 17s. So you must do this, you must answer this question using the prime factorization method only, not the long division method, because you'll have to give a reason. So this is more up. This method is more appropriate for this question. For this question, this method is more appropriate. If the question is to find the square root, then you can use the long division method also. Find the square root. Here it does not find the square root. Is it a perfect square and give reason? So you should use the prime factorization method. And then you must say, I told you this, because it can be expressed as the product of pairs of equal prime factors. I explained this in the last class. Because the number 56644 can be expressed as a product of pairs of equal prime factors. So see here, 2 2s, 2 7s, 2 17s. So it's a perfect square. So to answer this question, the prime factorization method is more appropriate. See you, darling. Yeah. Yeah, take on first question, children. Right? Okay. Yeah. So again, let's answer a similar question using a different number. Okay. Now, supposing we have 50 chairs. Okay, so we have 50 chairs and we need to arrange these 50 chairs in equal number of rows and columns. In equal number of rows and columns, meaning you'll be forming a square. Because if the number of rows is equal to the number of columns, the entire arrangement will look like a square. If the number of rows and columns are different, the arrangement will look like a rectangle. If the number of rows and columns are different, supposing 10 rows and 15 columns, then the arrangement will look like a rectangle. But when you have equal number of rows and columns, the arrangement will be like a square. Okay, so now supposing we have 50 chairs, and you want to arrange these chairs in equal number of rows and columns. 10 in a row, huh? 10 in a row, then 10 in a column. No. So supposing we have 50 chairs and we'll have to arrange the 50 chairs in equal number of rows and columns. Then you'll have to arrange the chairs in 7 rows and 7 columns. 7 rows and 7 columns because 7 sevens are 49. 7 sevens are 49. Okay, and 1 chair will be left out. Yeah. That's what. No, 1 chair will be left out. Yes, over here. Sorry. You can see from there, is it? Oh, I thought you will not be able to see. That's why. Okay, fine. Yes. Yeah. Yes, sir. Thank you. Bye. Yeah. So using 50 chairs, you cannot make a square actually. So you can arrange the chairs in 7 rows and 7 columns, but 1 chair will be left out. 1 chair will be left out. So this is the maximum number of rows and columns in which the chairs can be arranged. See, you can also make 6 rows and 6 columns. In that case, 14 chairs will be left out. Yeah, see you. This is the maximum number of rows and columns in which the chairs can be arranged. Maximum number of rows and columns, because you can also make 6 rows and 6 columns, right? You can also make 6 rows and 6 columns. Then you would have used up 36 chairs. Then 50 minus 36, 14 chairs will be remaining. So you can arrange it in different number of rows and columns. But the question is, find the maximum number of rows and columns in which the 50 chairs can be arranged. So the maximum, the highest possible is 7 rows and 7 columns, and 1 chair will be left out. Now answer this now. Supposing there are 30 chairs. Okay, there are 30 chairs. Tell me the maximum number of rows and columns in which they can be arranged and how much will be left out.
Ma'am, in 5 rows and 5 columns.
5 rows and 5 columns. And how many chairs will be left out?
5 chairs.
5 chairs will be left out. See, 5 rows. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 rows here. 1, 2, 3, 4, 5 rows and 5 columns. 1, 2, 3, 4, 5 columns. Now count the chairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And 5 chairs left out. Correct? So you should, the thing is you should find, we'll come to that later. Yeah, 1 minute. Is that okay? Okay. Now supposing you have 200 chairs. So if you guess, so don't use any procedure, just guess. Supposing you have 200 chairs. 200 chairs. What will be the maximum number of rows and columns in which you will arrange them? And what will be the number of chairs remaining?
Ma'am, 14, ma'am.
No. Yes, others, Anantika, Aishwarya, Ariston, Harsha, Lakshana.
Yes, ma'am.
Yeah, what's the answer, children?
Ma'am, I got 106.
So how many rows and columns? 196 is right. How many rows and columns?
106 rows and
Imagine there are only 200 chairs.
Ma'am, 14 rows and columns.
14 rows and 14 columns. 14 14s are 196. 14 14s are 196. So 14 rows and 14 columns will use up 196 chairs. See, we think 14 rows and 14 columns will need only 28 chairs. No. 14 rows and 14 columns will need 14 into 14, 196 chairs. No, you're not convinced, Surya? Yeah. So 14 rows and 14 columns will not just require 28 chairs. It will need 14 into 14, 196 chairs. So you have 200 chairs and 196 is close. So you can arrange the chairs in 14 rows and 14 columns and 4 chairs will be left out. Correct? No, we have to keep guessing till you understand. Supposing you have, let me take a smaller number, 150. You have 150 chairs. Okay, we'll just change the situation, no? We'll change the situation. So you're in your school and there are 150 in the playground, there are 150 students. 150 students have assembled in the playground, the school playground. 150 students have assembled in the school playground. The PT master comes from nowhere, he comes and he arranges you in equal number of rows and columns. And some of us are left out because we cannot fit into the square. All right, he arranges all of you in equal number of rows and columns, but all of them will not fit into the square. So some children, poor children, they'll be made to sit away. So tell me how many children will be accommodated in the square there? How many rows and how many columns?
Ma'am, 12 rows and 12 columns.
12 rows and 12 columns because 12 12s are
144.
144. 12 12s are 144. And how many children will be left out?
6.
6 children will be left out. They cannot be accommodated in the square. So you need to, remember square numbers to a certain extent. How much ever possible you try to remember. 1 1s are 1, like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 194, 225, 256, 281, 324, then what is 361, 400. So go on like that. Remember how much ever possible. You need to know the square numbers. What is 10 10s are, 11 11s are, 12 12s are, 13 13s are, 14 14s are, 15 15s are, 20 20 times, 21 21 times. If you remember those numbers, you can get the number easily. Otherwise, you just have to work. Otherwise, what should you do? You should try 11 11s are. You'll get 121. Then 12 12s are, 144. 13 13s are. You get 169. But there are only 150 students. So you go with 12 12s are 144. So 12 rows, 12 columns. In 12 rows and 12 columns, 144 students will be accommodated. So 150 minus 144, 6 children will be left out. They will not form a part of the square. Okay, one more, please, children. I think if all of you answer, then I'll be convinced that I have, I'm clear. I'll give a bigger number. Try like 21 into 21, then take bigger numbers. 13 to 30, do something like that.
Ma'am, I got the answer, ma'am.
Yes, Gayatri?
Ma'am, it's 24 into 24, ma'am, which is 576, ma'am.
Very good. Yes. 24 and 24. Okay, so 24 into 24. 24 into 24 is 576. 25 into 25. 25 into 25 is 625. But there are only 600. So the students will be made to arrange in, the students will be arranged in 24 rows and 24 columns. So in 24 rows and 24 columns, 576 students will be accommodated. And students left out will be 600 minus 576. 24 students will not form a part of the square. They'll be sitting outside the square. Now, if it is so like this, when the number is very large, you cannot always calculate like this, right? So you need to have a procedure, a format, or some method by which you can get the answer. So what you need to do is you just need to find the square root. You just need to find the square root, children. So you need to just find the square root using the long division method. And here, what is the remainder? The remainder is 0. That means all these chairs can be, arranged equally. All these chairs can be arranged in 106 rows and 106 columns. Your exams are going on or something? Your exams are going on? No, or is the blower making you shrink your eyes? Yes. Yeah? Sit away then. You sit away. Is it hitting you directly? Yeah? Yeah, then maybe you can just come away. Boys are comfortable? Yeah. The remainder here is 0. So that means these chairs can be arranged in 106 and 106 rows and 106 columns, and no chair will be left out. All right. In the next question, I'll give you time to write. In this question, when you find the square root using you have to use the long division method here. You should not use the prime factorization method. You have to use a long division method here. Prime factorization method will not help you to get the answer. You must use a long division method because remainder you will get only in the long division method. How much left out? That left out you can get only in the long division method. Remainder you get only in the long division method. In prime factorization method, you cannot find the remainder. Okay, so try to find the square root using the long division method. You get 71 as a remainder. So that means in this question, it's about soldiers. In this question, it's about soldiers. So these soldiers will be arranged in 273 rows and 273 columns, and 71 soldiers will be left out. And 71 soldiers will be left out. All right. Here, nothing left out. Remainder is 0. So all the chairs can be arranged in 106 rows and 106 columns. Yeah, write down, children. Take down the answer. Yeah, I've done this one. Yeah, take down the question and complete this answer. Shivam, right? Done, children? So Surya, tell me, how does this long division math work? Have you completed the long division? You finished? Or tell me, how does it work? Don't get upset on. Yeah. First, start with pairing the digit. Ah. Just tell me what you've written. Yeah. No. What? 2? No. 2. How many times? No, what have you written in your book? How have you completed the long division process? Tell me 2 2s are 4. Tell me the steps. Yeah. No, I want you to say it to understand if to know if you've understood. Okay. Ah. And 7. Then 47 3 2 9. Then I got 1,700. 1,700. 17 is a remainder and 0 comes down. Very good. Then very good, Suri. Okay, in how many rows can they be arranged? Yes, Shivam, in how many rows can they be arranged? There are 74,600 soldiers. In how many rows can they be arranged? Some number of soldiers will be left out. But how many rows and columns are formed? Yes, you, Shreya? 273 rows and 273 columns. Yeah. So how many rows and columns are formed? 273 rows and 273 columns. And how many soldiers are not a part of the square? 71 soldiers. They are standing alone. They don't form a part of the square. All right. Finished? Yeah. Online students?
Yes, ma'am.
Yes, ma'am, done.
All right. Select. ABCD is a square of side 15 centimeters. Don't write anything. Listen to me. ABCD is a square. ABCD is a square of side 15 centimeters. All sides are equal. So 15 centimeters all over. Find the length of the diagonal AC. Find the length of the diagonal AC. All right. Find the length of the diagonal AC. Okay. Now, do you know the formula to find the length of the diagonal? Do you know the formula to find the length of the diagonal of a square? Okay. Supposing you do it using the formula. Okay. Length of diagonal of a square or of square. 1 second. Root 2 into side of the square. Root 2 into side units. This is the formula. Root 2 into side units. So root 2 into 15. So 15 root 2. 15 root 2 centimeters. This is the length of the diagonal of the square. The formula is root 2 into side. Root 2 into side of the square will give you the length of the diagonal. This is using the formula. Now here, I expect you to answer this question using squares and square roots. So how do we do that? Take down this one, children. Using the formula, you can answer. Take down the question and answer it like this. We'll also see the alternate method where we use squares and square roots. So the formula to find the length of the diagonal of a square is given by the formula root 2 into side. Root 2 into side of the square units. So side is 15. So root 2 into 15, which is 15 root 2 centimeters. Done writing this, online students?
Yes, ma'am.
Yes, ma'am.
Done, ma'am.
All right. Now see how we can answer this using squares and square roots. So you understand this figure, ABCD is a square and you can see the diagonal AC here. So now in this right triangle ABC, it's a right triangle because every corner of a square is a right angle. Every corner of a square is a right angle. Okay, so use Pythagoras theorem in this triangle. In right triangle ABC by Pythagoras theorem, you need to square the hypotenuse and write it separately. Square, see, which are the three sides of the right triangle? Which are the three sides of the right triangle? AB, BC, and AC. AB, BC, and AC are the three sides of this right triangle. Okay. All right. Now, which is the hypotenuse in this? This is the right angle. So opposite to this is the hypotenuse. So AC is the hypotenuse. AC is the hypotenuse. So square all the sides. Write the hypotenuse square on one side equal to add the squares of the other two sides. AB square plus BC square. Always on one side you will have the sum of the squares of the legs. They are called the legs of a right triangle. I'll tell you what the three sides are called. Okay, this is a leg. This is a leg. This is also a leg. This is the hypotenuse. This is the hypotenuse. We know that the hypotenuse is the longest side in a right triangle. The remaining two sides are called the legs. Which is the hypotenuse opposite of the right angle is the hypotenuse. Leave the hypotenuse. The remaining two sides are called the legs. Legs of a right triangle. So Pythagoras theorem goes like this. Legs, one leg square. So that is like leg square plus leg square. That is one leg square plus the other leg square is equal to hypotenuse square. Is equal to hypotenuse square. Or you can write hypotenuse square is equal to the square of one leg plus the square of the other leg. You can write hypotenuse square is equal to square of one leg plus the square of the other leg. Or you can write one leg square plus the other leg square is equal to hypotenuse square. Anyways, you can write. But the square on the hypotenuse must be alone on one side. Okay, that should be alone on one side. The square on the hypotenuse must be alone on one side. And then on the other side, one leg square plus the other leg square. So in right angle ABC by Pythagoras theorem, this is the hypotenuse. AC is the hypotenuse. So you can see that separately here. AC square is equal to AB square plus BC square. AB square plus BC square. Correct? So we don't know AC. We have to find AC. So AC square is equal to AB is 15. BC is also 15. So 15 square plus 15 square. 15 square plus 15 square. Now what is 15 square? 225. 15 square 225. So AC square is equal to 450. AC square is equal to 450. So AC is equal to the square root of 450. I told you when you have to take the square to the other side, it will become square root. I told you in the last class, when the square, if you want to, get rid of the square, that is when you take this to the other side, it becomes square root. So AC is equal to the square root of 450. And how do you find the square root of 450? Find the prime, use the prime factorization method. 225 times. Then 3, how many times? 3 7s are 21, 75 times. Again 3, 25 times. 5 5s are 5 1s are. So you can see that 450 is 2 into 3 square into 5 square. 2 into 3 square into 5 square. So 2 into 3 square into 5 square. Correct? So square root of 450 is equal to square root of 2 into 3 square into 5 square. Now from 2 3s, 1 3 comes out of the square root. From 2 5s, 1 5 comes out of the square root. And the 2 remains under the square root. The 2 remains under the square root because it doesn't have a pair. It does not have a pair. It cannot come out. These 2 3s, 1 3 out. 2 5s, 1 5 out of the square root. But this 2 remains under the square root. Why? Because there's only 1 2. Yeah, so it cannot come out of the square root, so it remains under the square root. So the answer is 3 5s are 15, 15 root 2 centimeters. Now, I'm sure your question will be when you can do it so easily or quickly using the formula, why this method? You should also know that you can find it like this. You should also know that such a thing exists. Yeah, for that sake, I have presented the answer like this. In the exam, if this question is asked in the exam, you don't have to do this method. You can use a formula, root 2 into side and finish it. Nothing can be specified like this. It's difficult to put the question like that. Or if they say find the length of the diagonal AC using Pythagoras theorem, then maybe yes. Yeah, using Pythagoras theorem, then you have to do it like this. If nothing is mentioned, you can just use the formula root 2 into side and finish the answer in about 10 seconds. Otherwise, you have to do this procedure. Yeah, work this, children. As you work, if you have any question, please ask me. Take down this answer, all of you. Finished? Alfie? Done online. Sorry, finish writing online students.
Yes, ma'am.
Yes, ma'am.
Okay. All right. Yeah. So in this figure, we need to find the length of the side QR and the area of the triangle PQR. We need to find the length of the side QR and the area of the triangle PQR. Okay. So to find the length of the side QR, you can use Pythagoras theorem. So how do we use Pythagoras theorem? I told you, write the hypotenuse square on one side. So you can see here PR square. And then PQ square plus QR square. Sometimes they call this the base. They call this the base. They call this the altitude. And this one the hypotenuse. So it's like base square plus altitude square is equal to hypotenuse square. Base square plus altitude square is equal to hypotenuse square. All right. Base square plus altitude square is equal to hypotenuse square. Okay. So in right triangle PQR by Pythagoras theorem, PQ square plus QR square is equal to PR square. PQ square plus QR square is equal to PR square. See, write the hypotenuse square alone on one side. It can be in the LHS or the RHS. All right. Okay, now substitute whatever you know. PQ is 10, so 10 square. QR we do not know, so QR square is equal to PR square, so 26 square. Substitute the known values. Then 10 square is 100, 26 square is 26 into 26, which is 676. So now transpose. So QR square is equal to 676 minus 100. So QR square is equal to 576. Then QR will be equal to the square root of 576. If QR square is 576, then QR will be the square root of 576. And how do you find the square root of 576? This method. You should show that method. You cannot write 24 like this and leave it. You must find. See, when you are writing the answer, you cannot, after the step square root of 576, you should not write 24. You must use the long division method and find the answer. And then write 24. That procedure you don't see here. You should do it in the rough column. And 24. Now you found this 24. Now the area of the triangle PQR is half into base into height. See, it's given by different formula, half product of legs. I told you this is one leg, this is the other leg, right? I told you. Hypotenuse is one side. The remaining two sides are the legs. So we also say half product of legs. What do you mean by product of legs? One leg into the other leg. Or half into base into height. It's the same. Half into one leg into other leg or half base into height. It's the same. So if you write half product of legs, so half into I mention the legs PQ and QR. PQ into QR, 10 into 24. Simplify. 2 ones are 2 12s are 12 into 10, 120 centimeters square. All right. Yeah, please write this, children.
Mom, my laptop is running out of battery. Can I just go get my charger?
Yeah, sure. Done writing, children? Online students?
Yes, ma'am.
All right. Yeah. Yeah, you can. You can. Correct. 2 1s are 2 5s are. 24 into 5 is 120. Yes, yes. So the cancelling and all that, like it's not possible for me to type. Correct. So you cannot see the cancelling, but you have to do that. So like 2 1s are 2 12 times. You need to cancel. In your book, you should see all that, right? So please, simplification part, you will not see here. You should do it in your book. You can also cancel 2 and 10. 2 1s are 2 5s. 5 into 24 is 120. The simplifying part alone you cannot see here. So you have to do that by yourself. Okay. Next one. Find the smallest square number exactly divisible by 12, 15, and 24. Okay. Now, smallest square number, don't write square number, exactly divisible by 12, 15, and 24. Now we'll just take away the numbers square. So supposing we have to find the smallest number. Supposing we have to find the smallest number exactly divisible by 12, 15, and 24, then it is the LCM. Then it's the LCM. Okay. Which is a small 1 minute. 1 second. Smallest square number. Okay. What is the smallest number? My question is, what is the smallest number exactly divisible by 2, 5, and 10? Tell me. Guess. Which is the smallest number that's exactly divisible by 2, 5, and 10?
Ma'am, 10.
Yeah, oh yeah, 10. Yes, somebody said 10, right? Sorry, yes. So the smallest number exactly divisible by 2, 5, and 10 is 10 itself. The smallest number. 10 is divisible by 10. 10 is divisible by 5. 10 is divisible by 2. So 10 is, which is nothing but the LCM of 2, 5, and 10, right? Okay, let me change 10 to 15. Let me change 10 to 15. Now tell me the smallest number that is exactly divisible by 2, 5, and 15.
Ma'am, 30.
30. The LCM of 2, 5, and 15. 30. 30 is divisible by 15. 30 is divisible by 5. 30 is divisible by 2. And that's the smallest number. There is no number smaller than 30, which is divisible by 2, 5, and 15. There are numbers more than 30, like 60 also. 60 is another number, which is divisible by 15, 5, and 2. Like this, there are many numbers. All multiples of 30 for that matter. All multiples of 30. 60, 90, 120, 150, all the multiples of 30 also will be divisible by 2, 5, and 15. But the smallest is 30. And there is no number smaller than 30. There is no number smaller than 30 that is divisible by all these three numbers at the same time. Now you can say 10. Yeah, 10 is divisible by 2 and 5, but not 15. But not 15. So the smallest number that's divisible by all the three numbers is the LCM of the three numbers, least common multiple. is the LCM, and you all know how to find the LCM. Okay, the LCM is 30. The LCM of these three numbers is 30. Now, online students, am I clear? The smallest number exactly the smallest number exactly divisible by 2, 5, and 15 is the LCM of 2, 5, and 15, which is 30. Now the question is, what is the smallest square number? What is the smallest square number? For that, just one more step. What are the factors of 30? 2 3s are 6, 6 5s are 30. Okay. Now, if it has to be a square number, if the number has to be a square number, then every factor should occur in pairs. But in 30, 30 is what? 2 into 3 into 5. There's only 1 2, 1 3, and 1 5. But it should be, if it should be a square number, it has to occur in pairs, right? So you need one more 2, you need one more 3, and you need one more 5. That means what do you need in all? 30. You need another 30. Correct? So 30 into 30, that is the LCM into those factors which are needed to make it a perfect square. In this case, it is 30 itself, 900. This is the smallest square number, which is exactly divisible by 2, 5, and 15. See, there are two words, smallest number, smallest square number. The smallest number is the LCM. To find the smallest square number, you need to factorize the LCM. You need to factorize the LCM and understand if the prime factors are occurring in pairs. If it isn't occurring in pairs, leave that. Those which are not occurring in pairs, look at them. But here you see that nothing is happening in pairs. Everything is only 1. So you need to make 2 2 square, you need 1 2. Here you need 1 3 and you need 1 5. So 5 3s are 15 to the 30. So 30. So the LCM 30 into the required number 30 gives you the product 900. So 900 is the smallest square number. That's exactly divisible by 2, 15, 2, 5, and 15. Our example, 2, 5, and 15. So here in the same way, we need to find the LCM of the given numbers. We need to find the LCM because to find the smallest number, we are not finding the smallest square number first. To find the smallest square number, you should find the LCM. The LCM is this one. The LCM is this one. See, again, you don't have to multiply and get the LCM. You can just leave it like this because the question is not to find the LCM. The question is to find the smallest square number. You don't have to find the LCM. So this is the LCM. Now, which are the numbers not occurring in pairs? This one is happening in pairs. This 2, this 3, and this 5. Correct? So the LCM, this is the LCM. This is the LCM must be multiplied by a 2, 3, and a 5. So then it becomes 2 square, 2 square, then it becomes 2 square, 2 square, 3 square, and 5 square. And when you multiply, you get 3600. You should find. See, how do you find? You should find what is 2 square 4 into 2 square 4, 3 square 9, and 5 square 25. You should find this product. All that rough calculation you will not see here, children. So you don't write the answer directly. You should do that calculation. In your notebook, in the rough work, you should do the calculation. So 3600 is the smallest square number exactly divisible by 12, 15, and 24. So you need to first find the LCM. To find the smallest number, you should find the LCM. This is the LCM. Now to convert that smallest number to the smallest square number, you need to multiply that with, you need to multiply the LCM with 1 more 2, 1 more 3, and 1 more 5. So when you do that, you get 3600 and this is the required number. All right, children? Please write down.
Mom, I'm understanding till finding the smallest number, but I don't understand how you're finding the smallest square number. You're multiplying it with the same digit so that
No, suppose, okay. Now let's take, okay, all of you listen to me, children. Yeah, Aishwarya, yes. Thanks for that question, Aishwarya. Now, supposing we have some, LCM of some three numbers, okay? Some three numbers is supposing 2 square into 3 square into 5 into 7. Supposing the LCM of some three numbers happens to be 2 square into 3 square into 5 into 7. Now, this is the smallest number. This one is the smallest number. The smallest number is the LCM. Now you need to convert that to the smallest square number. So you see that 5 does not occur in pairs and 7 also does not occur in pairs. So you need to multiply the LCM, which is 2 square, 3 square, 5 and 7. This is the LCM. You need to multiply this with another 5 and another 7. So that the 5 becomes a 5 square and the 7 becomes 7 square. Now this product, you should find this. This is the required number. Shall I tell you once again, Aishwarya? Am I clear now?
Yes, ma'am, you're clear now. I understood.
Okay. So then Aishwarya, tell me for this one, supposing the LCM of some three numbers is 2 to the power 4 into 3 into 7 square.
Yes, ma'am. So right now we need to do we need to multiply 3 with another 3 so that it will become 3 square.
That's all right.
Yes, ma'am. And then we have to multiply the entire term.
Correct. So 2 to the power 4, the factor 2 occurs in pairs. 2 to the power 4, even power. It occurs in pairs. 4 2s, 2 2. So when the power is even, it's fine. 7 square also, the power is even, it's fine. 3 is alone. 3 is odd. So you need to multiply this with another 3. You need to multiply this with another 3. Yeah, take down, children. So the next half an hour will be a test. Complete this, and based on the same questions we understood today, we'll be taking a test now.
Done, ma'am.
Yeah.
Ma'am, I'll just be back in 1 minute.
Yeah. This one is the LCM. I hope all of you understand that. Shivam, see here till here. 2 square into 2 into 3 into 5. This is the LCM. This is the LCM. We need one more 2, one more 3, and one more 5. That's why into 2 into 3 into 5. And then 2 into 2 becomes 2 square. Then what happens? The next step, 2 square as it is. Then this 2 into 2 becomes 2 square. This 3 into 3 becomes 3 square. And this 5 into 5 becomes 5 square. Now see, every number occurs in pairs. So I should now multiply this. How? 2 square is 4. 2 square is 4. 3 square is 3 square is 9. And 5 square is 25. 5 into 5, 25. And this product is 3,600. All right. Done.
Done, ma'am.
Okay. All right. So all of you get ready for the test. Take on the first question. Take down the first question and answer it. Somebody's mic is enabled. Please disable your mic.
Yes, ma'am. What is the length of the rectangle, children? Ma'am, length of the rectangle or perimeter of the rectangle?
What is the length of the rectangle? 40.8 meters. What is the breadth of the rectangle?
10.2 meters.
10.2
Yeah, how will
meter.
you, correct. How will we find the area of the rectangle?
Length into breadth.
Length into breadth. L into B. Correct.
Yeah,
You should multiply. Yeah, 40.8 into 10.2 will give you the area of the rectangle.
Yeah,
Now you
ma'am.
got it. Now you got the area of the rectangle, right? Now what is the area of the square? What is the area of the square?
Side square.
No, I'm expecting a different answer. Find the length of each side of a square park whose
Ma'am,
area is
divided
equal
by
to the...
4. Answer divided by 4.
Ma'am, it's
children.
actually the same area as the rectangle.
Exactly. That's what I wanted. Yes, that's what the question says. There are two plane figures in the question. In this question, there are two plane figures, one rectangle, one square. And for the rectangle, we know the dimensions, length and breadth. So using that, you can find the area of the rectangle. Now, it is given very clearly in the question that the area of the square park is the same as the area of the rectangle. So whatever is the area of the rectangle is now the area of the square also. Now you got the area of the square. You got the area of the square. Area of the square is equal to something. You got it now. Now using, so if area of the square is known, how will you find the side? Yeah, children, you know the area. How will you find the side of the square?
Got the answer as 104.04.
No. Please answer this question. Once you know the area of the square, how will you find the side of the square?
Ma'am, divided by 4.
It's not perimeter to divide by 4. It's area. Perimeter divided by 4 is side. When you know the area of the square, how will you find the side of the square?
Once the area of the rectangle is equal to the area of the square, then like the length of the side of the square can be x. So then the area will be x square. And then we know that the area of the rectangle is the length and the breadth. So x square is going to be equal to the answer you get when you multiply length and the breadth.
Correct. So how will you find x?
And then I think that we take the square root of...
Correct.
Yeah.
Square root. Square root. Square root. Didn't we do in the homework question, children? 1 minute. Let me go back to that. Which one are we doing now? See here. See here. Area of the homework question. Area of the square park is this. So that means side square. What is the area of the square park? Side square is this one. So side will be equal to the square root of the area. Side is equal to the square root of area, and you have to find the square root of this number, and this is the side of the...
Ma'am, I got the answer as 20.4.
To find the perimeter. Yeah. So in the same way, children, now coming back to this question.
Ma'am, I got the answer as 20.4.
1 second, which was it? 1 second. This was 4.
Yes, even I'm getting the answer as 20.4.
Yeah. What's the answer?
20.4.
20.4, correct.
20.4 meters.
Yeah, complete this one. So it's all about reading the question carefully and understanding the information given. Don't jump into answering it before understanding the question. So what are the two plane figures here? Square and rectangle, the two plane figures or the two characters in this question. Yeah, rectangle and square are the two characters in this question. For a side, we know that all the sides are equal. Sorry, for a square, we know that all sides are equal. Rectangle, two sides, yeah, opposite sides are equal. And for the rectangle, we know the length and breadth. So for the rectangle, you know the length and breadth. So what can you find? You can find the area, you can find the perimeter, whatever you want, because you know the length and breadth. But what is given in the question? The area of there is this square park. The area of the square park is equal to the area of the rectangle is given. So what will you do with the dimensions of the rectangle? What will you do with that L and B? You will not find perimeter. You will find area of the rectangle. Because it is given that the area of the rectangle is equal to the area of the square. So why will you find the perimeter of the rectangle? You will find the area of the rectangle. Area of the rectangle is equal to L into B. All this you know. Now it's given that the area of the square is equal to the area of the rectangle. And that means the area of the square is 416.16 meters squared. So that means side square, correct? Side square is equal to this one. So side is equal to the square root of 416.16. So you need to find the square root of that number using the long division method. And you get 20.4. What is this 20.4? The side of the square. Now we found the side of the square. The question is to find, yeah, that's it. Find the length of each side of the square part. Yes. If you have to find the perimeter, multiply this one by 4 to find the perimeter. Because perimeter of a square is 4a or 4 into side. Okay. Now I think I'll just give you some time to go through the classwork. So next class we'll take up the test. We'll continue with today's session. Yeah. Children, I'll just explain these four. Maybe you can, because we have 15 minutes more. I'll explain all. They're very easy. I'll explain all this. You can complete them. You can complete them before the next class on Wednesday. All right. So today what I'll do is, what happens? What's Oh, you thought it moved by itself? Then you're scaring me also. After you people leave, I'll be alone here for some time. Okay. Yeah. Yeah. So today what I have to do is I have to share the pictures of the answers to the homework I gave you in the last class. So those who have not completed the homework, kindly use the pictures and complete it. So that's one thing. Last class homework answers, I'll share it on WhatsApp. Okay. That we already discussed in today's class. But for everyone's benefit, if you want to check it again or whatever you want to complete it, or one thing was incomplete, something like that, you can use the pictures. And the other thing is, we'll discuss the answers to these 4 questions in the class. I'll share these pictures also so that you can complete them before you come to the next class on Wednesday. So 2 things. This one, see, if you can't finish it, try to finish it by Wednesday. No homework, meaning no other homework will be given for Wednesday. Just these 4 sums you'll have to complete. Okay. Now, remember this, children, if you have to find, yeah. Now, there can be 4 questions here, you know. 4 questions here. Now, supposing a number is not a perfect square, what is the least number that is to be added? Or what is the least number that has to be subtracted? What is the least number by which it should be multiplied? What is the least number by which it should be divided? Now consider this number 40. Okay, 40 is not a perfect square. What is the least? You can guess. You don't have to work. You can guess. 40 is not a perfect square. What is the least number? That is the smallest number that is to be added to 40 to make it a perfect square. Quick. Very slow. What is the smallest number that is to be added to 40 to make it a perfect square? 9. 9. 9 is the smallest number. What is the smallest number by which it should be subtracted? Okay, what is the smallest number that is to be removed from 40 to make it a perfect square? 4. 4. What is the smallest number by which it should be multiplied to make it a perfect square? For this, you should just, for this, break down 40. What is 40? 8 5s are 40. And what is 8? 2 cubed into 5. 2 cubed into 5. Now, this 2 cubed, no? So you need one more 2 to make it in pairs. You need one more 2, and then 5, you need one more 5. So 2 5s are 10. 10 is the smallest number. 10 is the smallest number by which it should be multiplied to make it a perfect square. And 10 is also the smallest number by which it should be divided to make it a perfect square. Because 40 into 10, 400 is a perfect square. And 40 by 10, 4 is also a perfect square. So the questions can be like this. 9 is the smallest number to be added to 40 to make it a perfect square. 49 is a perfect square. 4 is the smallest number that should be removed from 40 to make it a perfect square. 36 is a perfect square. Now, for multiplied and divide, and the number to be divided, take up 40. What is 40? 2 cubed into 5. Find the prime factors. Find the factors like this. 2 cubed into 5. Now, 2 cubed, you need one more 2, right? To make it a, meaning it's not in pairs. It's not occurring in pairs. The power is not even. So you need one more 2, right? Surya, don't get that? Yeah, sure. Now I'm saying 40. 40 is 2 cubed into 5. Is that fine? Okay. What are the factors you see? What are the primes you see here? 2 and 5. Now, is the power of 2 and 5 even or odd? Or both odd, no? That means you can't make pairs. There are 3 2s. These 2 will become one pair. This 2 will stand alone. And 5 is only one 5, so it's not a pair. It's not a pair. Oh. So it's not a pair. Just ask them to come in and sit down. You can, yeah, you can go there and tell them. So I'm saying, இங்க வந்து உட்கார்ந்துக்கோங்க. என்ன மேடம்? அப்படியா? இல்ல அவங்களுக்கும் தெரியும், நீங்க தான் புதுசுன்னு நீங்க அப்படி. Yeah. So you know that 40 is what, children? Oh, I think your dad, huh? Oh, ask him to come inside and wait. So 2 cubed. Yeah. 2 cubed into 5, right? 40 is 2 cubed into 5, right, children? So 40 is 2 cubed into 5. Yeah, online students. So now the power of 2 is 3. It's odd. You need to have, see, you have 2 into 2 into 2 into 5. Correct? So this one stands alone. So you need one more 2 to make it a pair. Here this 5 also. You need one more 5. So what is 2 into 5? 10. 10 is the smallest number by which it should be multiplied to make the perfect square. And what is 40 into 10? 400. Correct? Similarly, 40 divided by 10 is what? 4. So 400 is a perfect square. 400 is a perfect square. 4 is also a perfect square. All right. So when a number is not a perfect square, you can find the smallest number to be added to make it a perfect square. The smallest number by which it should be subtracted to make it a perfect square. The smallest number by which it should be multiplied, divided to make it a perfect square. So the questions can be of these types. Now, what is the question here? The first one. What is the least number to be added to make it a perfect square? So this is not a perfect square. This number is not a perfect square. What is the smallest number that should be added to this one to make it a perfect square is a question. Now we know two methods, right? We know the prime factorization method to find the square root, and we also know the long division method. Correct, online students? What are the two methods in which we can find the square root of a number? Online students? Lakshina, Anantika, Harsha, Gayatri, Ashwarya.
Ma'am, long division and prime factorization.
Yes,
Prime
ma'am.
factorization.
Yeah, long division method and the prime factorization method. Now to answer this question, what is the least number to be added?
Ma'am?
To answer this, yes.
Ma'am, will you be teaching the repeated subtraction method?
Repeated, yes, yes.
Okay.
Yes, yes. Yeah. Yes, really. So to find the least number to be added, you should not use the prime factorization method, because where will you get a remainder? Where will you get a remainder? Only the long division method. Only the long division method you will get a remainder, correct? So if you want to find the number to be added or subtracted, if you want to find the number to be added or subtracted, you need to get some remainder. And that remainder you will get only in the, it's called, no, is it cold? I asked you. Sorry. So to find the number to be added or subtracted, you need some remainder. And remainder, where will you get? In the long division method. So you have to use the long division method. Now find out, I told you homework, but let's see how you find the square root. Or if you take on the first question you see here and find the square root of this number by the long division method. It's not a perfect square. You will not get remainder 0. It's not a perfect square. Then the question is not meaningful, no? 0. 0. If it's already a perfect square, 0 is to be added. Children, take down the first question and find the square root of the number 15,130. To find the least number to be added or subtracted, you need some remainder. And that remainder can be obtained only in the division method, long division method. So you have to use the long division method here. Shivam, not Shivam. Oh yeah, Shivam, right? Come here and do it. Let me see. You know the long division method? You know the long division method? You completed the notes from the recording? No, the long division method you understood or no? No, right? Okay, you have to watch the recording and I'll give you one more class. Next Monday, you should be ready with everything. Okay? I'll share all the recordings with you. Yeah, so now you have to wait. You cannot do this then. You have to wait. Got it? Completed online students?
Ma'am,
Yes, Lashana.
ma'am, I got the reminder as one.
What's your remainder?
One.
One. And what's your quotient?
123.
123. Let me check. Perfect. 123 and 1. 123 is the quotient and 1 is the remainder. Now the question is, yeah, children, you'll have to listen now. The question is, what is the number to be added? What is the number to be added? That means you should make this number bigger, right? What is the number to be added? Meaning you should make this number bigger. Bigger. Added meaning you should make it bigger. So what you do, take the successor. Take the successor of the quotient. What is the successor of the quotient? 124. Find the square of 124. That is 124 squared. It is this number. And now find the difference between 15376. That is the successor of 123. 124 squared, which is 15,376, and the number given to us. The difference is 246. And now 246 is the smallest number to be added to make it a perfect square. I repeat the method. Now you need to add something to this, meaning you need to make this number bigger. The procedure is take the successor of the quotient. What is the successor of 123? 124. Find the square. Find the square of 124. That is 124 into 124. Find 124 into 124. The product is 15,376. Now this is a new number. Minus the number which is given to you, 15,130. The difference is 246. Now that's the number. So 246 is the smallest number that is to be added to make it a perfect square. Understood the procedure? To find the smallest number to be added, find the square root. See, when you have to add or subtract, you need some remainder. So we use the long division method and not the prime factorization method. Remember that. Next, after completing the long division method, you get remainder 1, which itself shows it's not a perfect square. That's why you're getting a remainder. What is the procedure? Take the successor of the quotient, 124, square it. What's the answer? 15376. What is the number given? 15130. What's the difference? 246. And that's the smallest number to be added. All right. Is that fine, children? Okay, I'll share this image on WhatsApp.
It is, we have to find the successor of the answer, and then we have to multiply it by itself, so find the square, and then we need to subtract it from the original number that we had.
No, sorry. There was another student asking something here, so I couldn't listen to you completely. Actually, 1 minute, yes. The remainder is? No, this is not the regular division, so it's not like, it doesn't work like that. It's not the regular division, right? It's a special division, this one. What you're saying is for the regular division, meaning the usual division we do. No, that doesn't work here. Yes, Aishwarya, please come again.
Ma'am, so whatever number we get as the answer, we have to find the successor and then multiply it by itself.
Yeah, find the square of the successor. Yes.
Okay.
Yeah. Did you ask that?
Yeah. Is that why?
Come again? Yeah, come again.
123 then 1. That's how we find the.
No, the remainder can be 2 also. No, if the remainder is 2, you will not add 2 to the quotient. No, I told you, no, it's the successor of the quotient. It's no, I didn't know. There's not, the remainder has got nothing to do with this procedure. Whatever be the remainder, irrespective of the remainder you get, we are just considering the quotient. Irrespective of the remainder can be 1, 2, 3, 4, whatever be the remainder. We are not concerned about the remainder. We are only concerned about the quotient and the successor of the quotient, which is 124. Yeah, so even if the remainder is 2, doesn't mean you're going to add 2 here. No, it's regardless of the remainder. It is regardless of the remainder. Whatever be the remainder, it's always a successor of the quotient. Okay. Yeah, please complete this one, children. It's time. Done writing? Sorry. Done, Shivam? Finished? Online students? Completed?
Yes, ma'am.
Yes. All right. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Bye, ma'am. Thank you. Good night.
Thank you. Good night,
Thank
children. Good night, children. Thank you.
Thank you, ma'am.
Yeah.